Ladies and gentlemen, we are looking at notes 5.3, which are on evaluating trigonometric ratios for angles between 0 degrees and 360 degrees. So the first thing we need to do is we need to get a bunch of definitions out of the way, because everything that we're learning is based on these definitions here. So the first thing that I want to talk about is the standard position. So if you guys take a look, I want to draw a picture before we define it. So it says it's an angle in the Cartesian plane. So here's our Cartesian plane. We've got x and y, and this right here is 0. And now we're going to start to put trig in the Cartesian plane. So what's going to end up happening is we have an angle on the Cartesian plane that would end up looking like this right here. Okay, and this x-axis piece right here, this is called the initial arm, because this is where we're going to start measuring our angle, and this is our angle theta. So again, since this is initial, we start measuring our angle right here, and then it brings us to the other arm. This is called the terminal arm, the arm where it ends, where the angle ends. Okay, so that's our terminal arm right here, and this pink piece right here is our actual angle, and it's measured by angle theta here. Okay, so standard position is an angle in the Cartesian plane whose vertex, this right here is our vertex, whose vertex lies at the origin and whose initial arm lies on the positive x-axis. So it always lies on the x-axis where the x values are positive. So on the positive x-axis. The angle is measured from the initial arm to the terminal arm, and that is angle theta that we have right here. Okay, now for related acute angle and principal angle, I want to draw a picture of that for you guys as well. So again, we're on the Cartesian plane. We've got different quadrants. So here's quadrant 1, quadrant 2. We're going to look at the angles in all 4 quadrants, quadrant 3 and quadrant 4. Okay, this is still our origin right here. This is still going to be our initial arm, and we'll add the word arm up here as well. So this is still the initial arm. This is the x-axis, but this time our angle is not going to be acute. I'm going to show you what happens if our angle is not acute. So if our angle ends up being like this right here, then this whole piece right here is our angle. So this is angle theta. Okay, so from here, from the initial arm until our terminal arm, so this is still our terminal arm, this is still called angle theta, and this is called your principal angle. So it's allowed for this principal angle to be a large angle or a small angle, okay? Then the acute angle is the angle that is made between the terminal arm and the closest x-axis to it right here. So this right here is going to be your related acute angle, okay? And since theta is our principal angle, we'll call beta, our Greek letter beta, is going to be our related acute angle, okay? So the related acute angle is the acute angle between the terminal arm of the angle in standard position and the x-axis. The principal angle is going to be the counterclockwise angle. So if it's a principal angle and it's considered positive, then it's going to be counterclockwise. So notice how our angle started at the initial arm and went counterclockwise. Between the initial arm and the terminal arm, its value is anywhere between 0 degrees and 360 degrees. Okay, and now this is the positive angle. A negative angle is not measured counterclockwise, it's going to be measured clockwise. So an example of a negative angle would be, here's x, here's y, we've got 0 right here. Our negative angle right here is what we would get because we are measuring it now clockwise. Okay, so standard is counterclockwise, negative is clockwise. All right, so if an angle is in standard position, we can work out each of the angles in the other quadrants. So the first question that we have is 30 degrees. But the first thing I want to do is I want to label this as 0 because that's our origin. This is 0 degrees, okay? This up here is going to be 90 degrees because this is a right angle. So that means that this is 180 degrees, which would bring us back to 270 down here. And then over here, we can also call this 360 degrees. So if I had a 30-degree angle, it would look as follows. And this right here is 30 degrees. Now, I want to find out the same angle in all my other quadrants. So in quadrant 1, it's considered 30 degrees. Now, in quadrant 2 right here, the related acute angle is 30 degrees, but how many degrees is it to go from my initial arm right here to my terminal arm right here? So this right here, a full half circle right here is 180, and it's 30 less than that. So this right here would be considered 150 degrees. So 150 is one possible answer. Okay, now we have another angle down here that's 30 degrees, again, away from our x-axis, because that's what the our acute related angle is. So I'm going to figure out how many degrees it is altogether. Well, right here, I'm going to go from the initial arm all the way to my terminal arm. So from here to here, again, is 180, plus another 30 is 210 degrees. So we can also say that we have 210 degrees. And I'm just going to color code this so you guys can see what I'm talking about. So this angle up here is considered 150. The green angle is considered 210 degrees because it's been 210 degrees since our 0 degrees right here. And then our last angle that we have here is this one down here. And this one down here is 30 degrees away from our x-axis. So I can say I went 180 and then another 270 and then almost a full 360, but I'm 30 away from that. So this angle right here would be 360 minus 30 or 330 degrees. Okay, so those are our three answers right here. Okay, so let's do this again with our 45-degree angle right here. So this is our origin 0, 0. This is 0 degrees or 360 degrees. This up here is 90 degrees. We've got 180 over here, and then we've got 270 down here. Okay, and if we have 45 degrees, we know that that's halfway between 0 and 90. So this is going to be my 45-degree angle right here. We'll say this is 45 degrees. So the other angle in quadrant 2, so here's quadrant 1, here's quadrant 2. In quadrant 2, our angle will end up looking like this right here, and this is 45 degrees. So since this is 45 degrees, I want to figure out how many degrees it is altogether. So I know that the full half circle is 180, so I'm going to do 180 minus 45, and that's going to tell me how far I went to get to here, which is 135. So one of my answers is going to be 135 degrees. Okay, and then for the next answer, it's going to be in quadrant 3. So for quadrant 3 down here, it's another 45 degrees from our x-axis. So it's going to be 180 plus another 45. So this right here is going to be 225 degrees. Okay, and then our last angle that we have here is this one over here, and this is 45 degrees with the x-axis right here. So if it's a full 360 all the way around, I'm going to do 360 minus 45 will give me 315 degrees for each one of my angles. So let me just label this for you guys so we can kind of see this a little bit better. So that means that this up here was 135 degrees, this is 225 degrees, and then over here, this one over here is 315 degrees. I would like you to please try the 72-degree angle, and then we will discuss it when I see you guys in class. All right, so let's take a look at question number 1. It says, let's consider a circle centered at the origin with a radius of 5. So I'm going to call this x, I'm going to call this y. We've got 0 here. I've got 5 up here, 5 all around. and these are going to be points on my circle, and I'm going to go ahead and draw my circle. Try to draw your circle as best as you can. So it says if you choose the point 3, 4 on the circumference of the circle, so I'm going to go to 3, 4, 1, 2, 3, 1, 2, 3, 4. This right here is point P. I want to find the primary trigonometric ratios for the principal angle. So right here, if you notice, this creates this angle right here, and this angle here, we'll call it theta, okay? So I want to know what are my primary trigonometric ratios. Well, in order to figure this out, I need to have a right triangle. So I'm going to draw in my right triangle right here. This angle inside of here is angle theta, okay? And then we have a right triangle right here. So I'm just going to draw this a little bit smaller so you can see it a little bit better. So this is theta right inside of here, and this is 0. Okay, so in order to figure out all of my ratios, I'm going to just use SOHCAHTOA. Okay. Now, since my radius is 5, I know that my hypotenuse right here is also going to be 5. Okay, since this point is 3, 4, I know that the height of my triangle here is 1, 2, 3, 4, and I know that the base of my triangle down here is going to be 3. Okay, and since this is my angle right here, I can say that the opposite is my 4, that the adjacent is 3, and that the hypotenuse is 5. So if I want to find out what sine of theta is, all I have to do is take my opposite, which is 4, divided by my hypotenuse, which is 5. So it's 4 over 5. If I want to find cosine of theta, I'm going to just do the adjacent over the hypotenuse, so I get 3 over 5. Okay, and then if I want to do the tangent of theta, all I have to do is the opposite over the adjacent, so I would get 4 over 3. Okay, so then it says to determine the related acute angle and the principal angle to the nearest degree. So I can use any one of these equations I want, and I can use that to solve for theta. So let's just use sine of theta is equal to 4/5, because that's the first one I see. So I'm going to say theta is equal to the inverse sine of 4/5. So I'm going to go ahead and do that. I'm going to type in 4 divided by 5, press enter, and then I'm going to do the inverse sine. So I end up getting that theta is approximately 53 degrees. So here I know that theta is approximately 53 degrees. So first thing it asked me to do is find the related acute angle. So 53 degrees is an acute angle. So therefore, the related acute angle is 53 degrees, okay? And it also asks for our principal angle. Well, our principal angle is from our our initial arm to our terminal arm, but here it ends up being the acute angle that we originally had anyways. So the principal angle is also 53 degrees. And I'll show you an example where the principal angle and the acute angle, the related acute angle, are not going to be the same answer. Okay, so now this time, question C says if you chose the point -3, 4 on the circumference, so I'm just going to draw a rough sketch of it so I don't have to keep going back and forth. So if I were to choose the point -3, 4, then this would be my point right here. It would be -3, 4. So this is what my triangle would end up looking like. This has a length of 3, but the coordinate itself is -3/4, okay? So we'll say that it's -3 here. We have a height of +4. So it's the same idea, except now we're in quadrant 2 instead of quadrant 1, and we're still going to use SOHCAHTOA, okay? And this time, we're going to call this angle beta, okay? So right here, we're going to say that the sine of beta is equal to the opposite, which is 4, over the hypotenuse. Sorry, I forgot to label that the radius is still 5. So it's still going to be 4 over 5. The cosine of beta, though, is where things get a little bit different. So the cosine here, the x value right here is -3, and the sign does matter. So the adjacent here is -3, and the hypotenuse is 5. So it'd be -3 over 5. And then our tangent of beta right here is going to be the opposite over the adjacent, and it's 4 over -3. So it's going to be a -4/3 as our answer. So here what ends up happening is we end up getting a sine is positive, our cosine is negative, and our tangent is negative as well. So it's the same idea though. To solve for beta, it's exactly the same if I use sine. So here, sine of beta is equal to 4/5. I'm going to say beta equals the inverse sine of 4/5, which we already did. We ended up getting that it's approximately 53 degrees. But here's the thing that we need to be aware of. This beta inside of here is 53 degrees. So that's the related acute angle. So therefore, the related acute angle is 53 degrees. But the principal angle is 53 degrees away from 180, because remember our principal angle that we have here is going to be from the positive x-axis from our initial arm all the way to our terminal arm. So this is our principal angle right here. So we're going to say, therefore, the principal angle is, now if it's 180 to get to the other side of our x-axis, then it would just be 180 minus 53, which ends up giving me 127 degrees. So this whole angle right here is 127 degrees. Okay, and if you have any questions, let me know and I'll help you out. Okay, so for each ratio, question number 2, it says use a sketch to determine which quadrant the terminal arm and the value of the related angle will be, as well as the principal angle. And I'm sorry, I know the language here is kind of weird. We want to find the quadrant of the terminal arm and then the value of the related acute angle as well as the principal angle. So right here, here's 0, here's 90, here's 180, here's 270. So if I want tan of 220, then this is going to be my angle. My angle is going to be somewhere around here. So this full angle right here, the blue angle, is going to be my principal angle. And we'll say that our principal angle is going to be theta in all of these examples here. So theta is going to be equal to 220 degrees. Okay? Now, the related acute angle is going to be how the angle that it makes with the x-axis right here. So if this goes up to 220 and this is 180, the difference between the two is going to be your related acute angle. We'll call that angle beta. So angle beta would be 220 minus 180, or 40 degrees. So angle beta here is 40 degrees. Okay? And then lastly, it asked us to figure out which quadrant it's going to be. So since this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, our answer is going to be in quadrant 3. So those are the answers to our questions. All right, let's do the same thing for sine of 100 degrees. So right here, again, 0 degrees, 90 degrees, 180, 270. We've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Sine of 100 would end up being right over here. So this right here, this theta value right here is going to be 100 degrees. Okay, now to figure out what the related acute angle is right here, so I want to figure out what this related acute angle is going to be. So right here, how much is this right here? It's going to be 180 minus 100, okay? So angle beta is going to be 80 degrees. So that's what our related acute angle is going to be, and it is in quadrant 2. Okay, I'd like you to try part C and we will compare with each other in class to see how you got, or what you got. Okay, so number 3, instead of using opposite, adjacent, and hypotenuse for our trigonometric ratios, we can change these based on the Cartesian grid. So right here, this is going to be our x value right here. So we'll call this x, and we'll call this y. And this is always going to be the result of some type of a circle. So I'm just drawing a random circle. And when we have our circle, we always have a point on our circle that we use to create our triangle right here. Okay, and that triangle always has our angle theta in it. So this right here is going to be my radius always of my circle. The hypotenuse is always the radius. Okay, now the next thing that's really important for you guys to understand is it always goes through a point on the circumference of your circle, and that point always has a coordinate x comma y. Now the x value right here is always going to be the bottom part of your triangle, and then the y value here is always going to be the height of your triangle, always. So instead of using SOHCAHTOA, what we're going to do is we are going to say that the sine of theta on the Cartesian grid is always going to be the opposite over the hypotenuse. So here the opposite is your y value and your hypotenuse is the r, always, okay? And then if we have cosine of theta, it's always going to be the adjacent over the hypotenuse, so it would be x over r, okay? And then the tangent of theta is always going to be the opposite over the adjacent, or y over x, always. Okay, so now let's go ahead and do our reciprocal ratios as well. So the cosecant of theta, instead of doing opposite over hypotenuse, we'll do the hypotenuse over opposite, so it'd be r over y. The secant of theta would be hypotenuse over adjacent, so that would be r over x. And then the cotangent of theta would be the adjacent over the opposite, so it would be just simply x over y. Okay, so question number 4 says to use the point P01 to determine the value of sine, cosine, and tangent for 90 degrees. So if you guys notice right here, if I were to use the point 01, then this right here is the coordinate 0, 1. If you notice, it happens right at 90 degrees. So to figure this out, I would do sine of 90 is going to be equal to the y value, which is 1, over the radius of my circle, which is also going to be 1. So sine of 90 is 1 over 1, or just 1. Okay? The cosine of 90 is the x over the radius, so the x is 0, so I would do 0 over 1, or just 0. Now, the tangent of 90 is where things get a little bit trickier. So the tangent, we figured out, is going to be the y over the x. Well, if the y value is 1 and the x value is 0, I would do 1 over 0, so that's going to be undefined. Okay, so that's what I want to talk to you guys about for this video. We'll continue 5, 6, and 7 next time I see you guys in class. Have a great day.